So I've taken the main ideas that these three students did in their dissertations and applied them to one excerpt of chat log. In the virtual math teams project. And it's related to the idea of intersubjectivity or common ground or the joint problem space. So intersubjectivity means that people can understand each other, what each other says, and have a shared view. So the joint problem space is that they co-construct, a small group of people collaborating together, co-construct a space, maybe a conceptual space or a graphical space or whatever, that represents what they're working on. And I want to look in this case study at how they do that. How do they accomplish that interactionally? Jeremy convinced us that they do that, and it's really important for collaborative learning, supports the collaborative learning. So the question is, how do they do that? How do they establish and maintain their intersubjective understanding? And the domain is a math problem in the virtual math teams environment, which I think I'll show you. In terms of the theory of collaborative learning and computer support of it, what are the conditions that make collaborative learning possible? And there's this whole philosophic concept of intersubjectivity, which I'm trying to explore in an empirical way by looking at data of how people interactionally build that shared knowledge. And I'm trying to do it in a different way from the theory that's been widely accepted within CSCL of common ground, based largely on Clark's sociolinguistic approach, which is mainly a mental view of how people's individual cognition gets coordinated. And I'm looking at it in an interactional way rather than that. So basically, if you think about at a philosophical level, we exist as not as abstract intellects or minds, but we exist as embodied people within a social world that we share, the physical world we share. So within philosophy, there's been this problem of how is it possible not only to understand other people, because our minds are, encased in a skull different from the other person's mind, and that's a mental thing, and we exist in the same physical world, but how do the mental things get coordinated? That's just the wrong way of looking at it, and I turn especially to Heidegger and his concept of being in the world, that we're basically, that's not the right starting point. You start out by the fact that we're all in a shared world. So I think that solves the problem really for physical social life. But then it gets more complicated in CSCL because we're not in the same shared physical world anymore. In this case, there are several students. They're scattered around the world. They've never seen each other. They don't know anything about each other's physicality. They don't know their gender, their age, what they look like, any of that. All they know is what shows up in the chat log. So how do they then become part of a shared social world? And so we get this problem reappearing in this world, in this virtual world, where this is the representation of the people, just the little name, their login name, and whatever they happen to say in the text chat, and whatever they happen to draw in the shared whiteboard. So how does intersubjectivity get co-constructed in that kind of context, which is the sort of the primordial context for CSCL, the paradigmatic context. So I look at the chat log from the previous slide of the environment and look at what's going on interactionally among the different posts. And these indicate that some action was taken in the shared whiteboard. So it's really coordination of the text and the whiteboard. They're working on a problem of hexagons, and it's a mathematical problem of a series or progression. So you start with the simple hexagon and then look at bigger and bigger ones, and how does the area go up as you go from stage to stage. So that's the thing that they're exploring mathematically. So they start asking questions. What's the shape of an array? Well, so here first somebody proposes the mathematical problem. So it's something that the problem itself originates within the small group interaction. How could we calculate the number of triangles in a bigger hexagonal array? And then here's a sign that there's something that's not being shared. There's some understanding that's not intersubjective at this point. What's the shape of the array? So it's like the expression, what do you have in mind here by what you say? To put it in mentalistic terms, which they don't actually do. And then again, there's a problem. He says, wait, stop the discussion, because I don't understand what you're doing. I don't understand what you're looking at, what you're representing. Can somebody highlight the hexagon in the array? And then there's this work in the shared whiteboard. And here's a closer look. So here's the weight, and then a lot of activity. And what this person does is he outlines a big hexagon they started with just the array of lines that creates a whole hexagonal pattern. And one person wants to look here, like at the smallest possible hexagon, something like this one here. Consists of 6. You can see easily it consists of 6. Once you focus on it visually, you can see easily that it consists of 6. And then you want to look at larger hexagons like this bigger one. Well, how do you see those different size hexagons in this pattern? It's very difficult until they start doing things like picking this out. So this is a technique, a functionality in the system where somebody, when they post something, they can point to a rectangular array in the shared whiteboard. So you get this pointing. So I've been pointing things out to you here. I pointed out the smaller hexagon. I pointed out the bigger one. I can do that because we're in a shared physical world, but they're not. And so they need some kind of computer support to be able to do that. Or they need to discuss it at length in the chat. Or they need some drawing techniques, like this one person. So one person used the pointing functionality, and another person, or the same person, did this extra lines. So that's a technique they use to overcome the problem of a lack of intersubjectivity and to establish a common way of looking at this pattern. So then somebody asked, how do you color lines? So, because it was still confusing in the last slide. Now they've colored the outlining line in blue, and it's much more visible now. And so doing this kind of mathematics, it's very important to be able to see things in the representation, really see them in a visual way. Because the human eye is an important part of our cognitive abilities. And in fact, with mathematics, the human eye can tell you, without your having to do any kind of thinking in the cognitive science sense, it can count a couple of units. Just in the eye itself has that kind of computational power without you doing any thinking to yourself about it. And that's what they're doing. They're trying to count units. And to do that, to do it the same way and to understand what they're doing, they have to know what each other's looking at and be able to see it as the same thing that the other people are seeing it as. There's this concept of seeing as. It's very important in, for instance, Wittgenstein and other philosophy. It's not that you see things in the way that sort of AI thinks about it as a grid with a certain resolution of points. That's not how we see things. We see things in meaningful ways. We see them as certain kinds of objects. we can look here and we can see this as a bunch of triangles, not points in an XY plane, but as triangles, as lines, as hexagons now. They're training each other to see it as hexagons, because that's what they're interested in. And then here, how do we count? So here in this bigger, encircled in blue, large hexagon, how are we going to count this? This is something that the eye can't do automatically. The eye sort of only counts up to 3 or 4. This goes beyond that. And here one student has an idea. It might be easier to see it as the 6 smaller triangles. What does that mean? How would you understand that if you were chatting and somebody said that? Well, other people don't really understand it. So what somebody does is they draw in red lines that divide up the bigger pattern into 6 symmetrical patterns. Each of the 6 smaller patterns has the same number, and you can almost count it visually, or at least easily go 1, 2, 3, 4, 5, 6, and then multiply it by 6, and you've got the total number. So that's a trick they're using, and they want to share that, and so they put these red lines in to help people see how they're seeing it, the bigger hexagon, as consisting of 6 smaller hexagons. And here, even more complicated, how many lines does it take? How many of these line segments does it take to build a bigger pattern? So here, they've taken the 1/6 of the bigger hexagon, and they've divided it very cleverly. At least one of the students has the ability to see these things as patterns with symmetries, high levels of symmetry. So one person saw the big hexagon as symmetrical around by dividing it this way into 6, which is a complicated thing. And then here they've colored in, and they see a pattern here, 1, 2, 3, and as you got bigger and bigger, they see it would be 4, 5, 6. And actually, these line-colored lines are identical in count to the purple ones and to the red ones. So if you count up just these, which is 1 plus 2 plus 3, multiply it by 3, then you get the number of line segments it takes to make this 1/6, and then multiply that by 6, you get the number of line segments in the big thing, which is quite a complicated thing. And you've done it in a way that your eye can almost automatically add it up. And so they want to share that way of seeing this. It's a very complicated way of seeing it, especially for younger children who aren't that experienced with it. And so they've invented this way of sharing it so that others can see it as what they're seeing it as, and by using these different colored lines and these symmetries and so on. So this is just one set of techniques that they've used to ground their intersubjectivity and to overcome problems in intersubjectivity, to repair potential misunderstandings, so that they can all see the representation the same way, and then they can work out a formula. They know that if it goes 1, 2, 3, then it's going to be a series. For any large hexagon, it's going to be a series that goes 1, 2, 3, 4, 5, 6, and so on. You add up, the set of consecutive integers, which there's a little formula that they already know about, and multiply it by 3, and then multiply it by 6, and you've got your answer, and you can do that algebraically as well. So they've established a joint problem space, so I did anticipate your argument here, that is visually shared, and they've oriented everybody to it, and they see it as a particular set, and then they can make it symbolic. So they move from the visual graphical representation to a narrative discussion in the chat to algebraic symbolism of the formula that they're looking for. And they do it step by step, keeping everybody together, keeping everybody seeing the same thing the same way. So these are my conclusions, is that this is some of the techniques that groups use to work on maintaining a shared view of the joint problem space. And in other studies that we've done, we've looked at how they use, so I looked here at, for instance, colored lines. But we also look in the text at questions, proposals, requests, repairs of misunderstandings, various kinds of pointing things out, outlining, and so on. So there's all these different practices that the group often develops. Some of them are obvious, just from our command of language. And some they actually develop and they share, like they asked, how do you color lines in this environment? That's something that one student knew, and they shared it so everybody could use those techniques. They confirmed their understanding by demonstration, not by saying, I know this, and I know you know that, and you know I know that you know that. That's not how they work. They do it by seeing it as a certain thing. And they're then able to accomplish their mathematical tasks. Here are the implications for CSCL. So it's possible to analyze all this stuff. You get the data. If you have this kind of data, you can analyze in great detail exactly how groups are accomplishing this. And if I had more time, of course, I would show more of it. I'd say more, but I don't. So that's it. The paper is here, and the slides are here. Thank you.
So we have 3 minutes left for questions.
Great.
And yeah, actually, if you want to get set up. Everybody tired of me today? Jim.
Jerry, how could that meta-group cognition transfer to other task domains? Did I miss that part?
What?
Did I miss that part earlier? I came in.
No. I only tried to do this one domain in my lifetime. This is why we need collaborations.
I mean, the
Right?
number of times people focus on that kind of a task as a group is relatively small. And in CSCL, we have a lot of ambition to make it focus.
The concept of seeing as.
Seeing as, yeah, for example, seeing as, how would that move to another domain? Any ideas?
Yeah, I think it moves to other domains. I mean, what domain? History? How do you see Nixon's visit to China? And how do you see that? You know, do you see it as he was coming here to exploit China, to bring it as an economic move, as a political move, as an ideological move? How do you see it? And if you're going to have a discussion with other people, you'd hope that either they would see it as the same way and as a basis for agreement, or they would share their differences in how they see it.
Yeah, I mean, history is a bit dramatically far, but maybe something like a simulation environment that they're trying to negotiate.
Yeah, so how do you see this widget?
Yeah.
You know, it's not just, like I said, it's not just the pattern of dots on an XY grid. It's representations of things that are supposed to be meaningful. They were meaningful probably in a simulation. They were meaningful to the designer of that simulation. So then the first question is, do the students who use the simulation see that thing as the same as what the designer intended? Do they see it as the same as what each other intended it as?
Okay, one more question.
So, I don't think we see that sort of intersubjectivity or group cognition all the time. So
I do.
you do? No, but in your data set, if it doesn't happen, so what are the conditions for such intersubjectivity to arise? When do you don't get those group cognition?
You get breakdowns in it, yeah.
Mm-hmm.
Right,
So
definitely.
what's causing, what do you think is to respond? And so if we want to cultivate
It's a fragile thing.
Mm-hmm.
It's a fragile social construction,
Mm-hmm.
and it has to be repaired constantly. And that's a very important part of group interaction, is repairing it. And conversation analysis, which is one way of analyzing, of seeing a log like this as a certain kind of interaction, recognizes that repair of broken of misunderstanding and of possible breakdowns of intersubjectivity is a very ubiquitous thing, and it's happening all the time, and it's very important to maintain the intersubjectivity. Otherwise, if you don't maintain it, then you can't do very much.
off. Next, we have Jeremy Rochelle. He's got his title up here, that CSCL is the missing link between